Watch the complete playlist on the app Pions. Download the app now.
4 capacitors are connected as shown in the figure. Calculate the equivalent capacitance across X and Y. So we have to find the equivalent capacity along X and Y here. Be very careful, there is nothing connected here across this wire. Okay, so if this is simply a wire, there is no capacitance of a single wire. Okay, because there is a capacitance for a capacitor, so this wire doesn't take into account any capacitance. But be very careful with the connections. How this wire is connected, that will decide many things, right? So X and Y, let's keep it as it is and let's try to simplify it. Let's make it as A, B, C, D. Okay. Okay. So first capacitor is connected across AB. Let's join this point A. Let's call it as A. I'm trying to redraw this. A, B. Across A, 2 microfarad. B, AB across AB, 2 microfarad, right? Now another wire which is connected from A and C. So basically, listen very carefully. This C point and A point, they are short. You can say that A and C both are same point, right? Why same, sir? Because A and C, they are connected with the same wire. Okay? So A and C will be at the same point. So you can say that another wire, which is 3 microfarad, that is connected between C and B. So C and B means C is nothing but A and B. So that can be drawn like this here. 3 microfarad like this. Now you will say, sir, how can I justify this thing that C and A are same? Okay, fine. Then let's call this as C. Great. I hope this is clear. So C and this I am connecting B, C here. So let's say that this wire, this is nothing but this wire. Nothing in between A and C, right? So if there is nothing, then you can say this as C, you can take this as C, you can take this as C, doesn't matter. I hope this is clear. So C and A are this point. So let me remove this, and to avoid any confusion, this is like this. Now from one end of the B, one wire is going across D, correct? And across this D, 5 microfarad is connected, whose one point is across C. So that C, let's call this as C. Let me remind you once again, this is our C. And one end is across C and another end is across whom? Across D. And that D is connected across B. So same thing. Okay. You can call this as C, you can call this as D, and this is our 5 microfarad. Correct. Let me repeat again this whole scenario. Pay attention once again. A and B, across AB you have one capacitor of 2 microfarad. Yes? Is it same? Yes. Between the two ends of A and B you have this. Across C and D, now from C, look at the C wire. Look at this C wire. One wire is going across A. Is it going across A? Yes, sir. From here it is going across A. Great. From C, one wire is going across the other end of 3 microfarad capacitor. Yes, sir. This is going over here. Same thing. And other end is going across 5 microfarad capacitor. Yes, sir. This is going across 5 microfarad. Which means this is correct. This diagram is correct. Our wires are connected perfectly. Let's talk about wire D junction or D junction. There are 3 wires. One wire is going across 5 microfarad, which is this one. From D across 5 microfarad. And from D, one wire is going across B. Exactly, it is going across B from here. And one wire is going from D to 10 microfarad. Okay. Okay. So we left with 10 microfarad. Let's write here D. And let's draw this 10 microfarad over here. Like this. Okay. Now you will say, sir, this is our Y. So where to keep X? This along this AC wire, you can put anywhere X. It doesn't matter that much. So let's take it from here only. Okay. Just to keep the consistency of our diagram. So let's say from A, this is our X, right? Okay. I hope this is clear. Great. So from D, one wire is going across 10 microfarad. This is 10 microfarad and those are in 3 in parallel. So if this is 2, this is 3 and this is 5. Okay. Let's solve this circuit and find the equivalent capacitance. So C equivalent will be equals to 2 plus 3 plus 5. So that is equals to how much? 10 microfarad. Sir, why you directly added? Because it's a parallel combination of capacitors. In parallel combination of capacitor, the equivalent capacitance will be the sum of individual capacities. Right? So let's redraw between A and D. So between A and D, our capacitor is 10 microfarad. This is our end A, which is going further to X. And this is our end D, which is further going to 10 microfarad and which is connected further to Y. Now 10 and 10, they are in series. So let's find C equivalent across XY. So 1 by CXY, that will be equals to 1 by 10 plus 1 by 10. So that will be equals to 2 by 10 and 1 by CXY. So C equivalent across XY will be equals to 10 by 2, which is equals to 5 microfarad. Done. That's our complete answer to this question.